This tutorial is on naming ionic compounds. Ionic compounds can be divided into three categories: metal and nonmetal, metal and polyatomic ion, and finally two polyatomic ions, which is a rare case. How do you know that a compound is an ionic compound? Well, if there is a metal, then it is an ionic compound. And how do you know if the element is a metal? You have to look at the periodic table, and as you can see here, all the elements to the left of the staircase are metals. Another thing that you will need to use when naming your ionic compounds is a polyatomic ions chart. You will have to know the name of polyatomic ions, their formula, and also their oxidation number, or this little charge that you see at the top right corner. Now let's get to the naming. If we have a metal and a non-metal, then we first write the name of the metal, and it's followed by the name of the non-metal with ending "ide." Let's go ahead and practice that. We have here NaCl. Na is the metal and its name is sodium, so we just write the name of our metal, sodium. Chlorine is the name of the non-metal, but we have to change its ending to "ide", and so it becomes chloride. Our name for NaCl is sodium chloride. Let's go ahead and try metal and polyatomic ion. It's very simple to name it. We just name the metal and it's followed by the name of the polyatomic ions. And the name of the polyatomic ion can be found in any polyatomic ion chart, or maybe you already memorized it. The name of the metal here is magnesium. So we write magnesium. And the name of polyatomic ion that can be found in the chart I showed you previously is phosphate. So we say phosphate. So the name of our Mg3PO42 is magnesium phosphate. Great. Now, how do we name two polyatomic ions? It's even easier. We just name the first polyatomic ion and then we name the second polyatomic ion, and that's it. NH4 is ammonium, so we write ammonium. NO3 is nitrate, so we write nitrate. And we get ammonium nitrate. Very easy. Notice that if our name ends in "ate" or "ite", then we have a polyatomic ion. Most of the time when our name ends in "ide", I-D-E, we have a nonmetal. Okay, now let's go to the harder case where we have to use Roman numerals. When do we have to use Roman numerals? Well, we have to use them if the metal has multiple oxidation numbers and is primarily for transition metals. How do you know if the metal is a transition metal? When we go to the periodic table of the elements, these metals in the midsection of the periodic table are called transition metals, and as you can see, they have multiple oxidation numbers. And for them, we will need to write a Roman numeral representing the oxidation number used in the formula. For example, vanadium, chromium, iron, we will see a lot of times, cobalt, etc. So let's look at the steps for writing the Roman numeral. Step number 1, separate the formula into two ions. Step number 2, find the charge or oxidation number of the nonmetal or polyatomic ion. For polyatomic ions, you can just look at the chart and see the oxidation numbers, which are the numbers that I showed you at the top right. For the nonmetals, we just look at the periodic table, and I can tell you right away to make it easier that group number 17 is always -1 and group number 16 is always -2. So that will make our life very, very easy because those are usually the two groups that get used. most of the time. Okay, so now, and this last step, number 3, is to figure out the oxidation number of the metal by crisscross multiplying process. It sounds a little harder than it really is. So let's go ahead and try it out. Here we have FeCl2. So the first thing we must do is we separate the formula into 2 ions. So we have Fe and Cl. And then we find the oxidation number of the nonmetal. If you look at the periodic table, Cl belongs to group 17 and therefore it has -1 oxidation number. Now the last thing we need to do is to figure out what is the oxidation number of iron. Well, the way that ionic formulas are written is that oxidation numbers get cross multiplied. So Cl oxidation number will go to the iron and iron oxidation number will go to the Cl. As we can see in this formula, Cl's 1 went to the iron, and that's why iron has 1 here. That is not seen, but that means it has a 1. And what did iron's number have to be to go to Cl and to put a 2 here? So its number had to be +2, because if we cross multiply them, we will get Fe1Cl2, which is exactly our formula. Now that we know iron's oxidation number, we can go ahead and write the full formula. This is a metal and a non-metal, and our metal is a transition metal. That's why we need to write the Roman numeral. So first we write the name of the metal, which is iron. It is followed by the Roman numeral, which we figure out here is 2. And then we write the name of the non-metal with the ending "ide." So we say chloride. Therefore, our name for FeCl2 is iron 2 chloride. Let's try another example. First, we ask ourselves, is this an ionic compound? Well, we see copper, it has a metal, and it has a polyatomic ion. Yes, it is ionic. Do we need to write a Roman numeral? Well, we check copper and we look at the periodic table, and we will be able to see that it is indeed a transition metal, and therefore we do need to write its Roman numeral. Great. Now we separate the 2 ions. We have Cu and we have PO4, which is a polyatomic ion. We check now the charge for the polyatomic ion in the chart, and the charge for polyatomic ion is -3. So we ask ourselves, what does the charge on copper have to be so that when they get cross multiplied, we get formula Cu3 PO4 2. The 3 next to the Cu came from PO4, and that makes sense. So therefore the 2 next to PO4 had to come from the Cu, and therefore Cu had to be +2. Now that we know its oxidation number, we can go ahead and write the name. The name of the metal is copper, so we say copper, followed by the Roman numeral because it is a transition metal. The Roman numeral is 2 because we figured out that that's the oxidation number of copper in this formula. And then we simply write the name of the polyatomic ion, phosphate.